today we're going to talk about apparent weight. Have you ever had a scenario where maybe you're riding a roller coaster and it feels like your stomach jumps into your throat and you feel like this weightlessness? Or you've been on an airplane that's taking off and for just a second as you're taking off, you feel like somebody's pushing down on you. You feel heavier than you normally are. Those feelings that you get are a result of your apparent weight. When you feel normal, like every day, just standing on the ground, sitting on a chair, your apparent weight is equal to your actual weight. But there are scenarios that you can experience where your apparent weight either gets heavier or lighter than your actual weight. That is what you feel. You feel your apparent weight, not my actual weight. My actual weight stays the same all the time, no matter what. Doesn't matter if I'm riding a roller coaster in an airplane, doesn't matter at all. But my apparent weight is what I actually feel, because we can only feel things that are actually touching us. So the big secret is that apparent weight is the normal force that's pressing on you. The phenomenon where you feel heavier or you feel lighter, that's because the normal force that you are feeling is changed. It's not equal to mg. It's not equal to my weight like it is right now as I'm standing here. Instead, I'm riding a roller coaster and I'm being shot straight up, like at Six Flags' Superman, Disney World's Tower of Terror. I'm being shot straight up, and I actually feel heavier than I actually am because the normal force acting on me is larger than my actual weight. Or as I fall on the Superman or the Tower of Terror, as I fall down, I feel lighter, I feel almost weightless because the normal force pushing on me is less than my actual weight. That's the idea of apparent weight. If I'm accelerating upward or downward, I can feel a normal force that is not equal to my actual weight. Feeling completely weightless would occur when my normal force is equal to 0, right? Weightlessness means I feel like my weight is 0. That occurs when my normal force is 0. So let's go through a couple of quick scenarios. Let's talk about the Tower of Terror, because it's my favorite ride at Disney World. So when I'm being shot upwards, I am accelerating upwards. My free body diagram looks like this still, FG and FN. Because I'm currently sitting in a chair, I'm strapped in, right? And I'm sitting in a chair and I am being pushed into that chair. Here's why. When I write out the Fnet equation, Fnet Y is equal to Fn minus Fg, I am accelerating upward. So this is going to equal MA. So my normal force is going to be equal to Fg plus MA. Since the acceleration is positive, this whole number is positive, so my Fn is greater than just Fg. So I feel heavy. When I'm going down, I am accelerating downward. So my free body diagram still looks the same. I'm still sitting in a chair. But now my Fnet Y equation, I'm still accelerating. So I'm still going to set this equal to MA. Here's the difference. This time, acceleration is negative, right? Because I'm accelerating downward. So I can write this as negative MA. So then Fn is equal to Fg minus MA, so Fn would be less than Fg. Now I feel lighter. So when I'm accelerating downward, I feel lighter. When I'm accelerating upward, I feel heavier. To feel completely weightless, right, I need to look at this equation because I want to feel lighter than I actually am. So to feel completely weightless, I would need M times A to be equal to Fg, right? I want these to cancel out. I want them to equal 0 so that I feel weightless. So in order to feel weightless here on Earth, I need my acceleration of whatever ride or scenario I'm going through to be negative 9.8. I need to be accelerating downward at negative 9.8 to feel weightless. So to feel weightless, my acceleration needs to equal negative 9.8 meters per second squared. Now, a quick note, weightlessness doesn't happen when you just like jump out of a tree or out of an airplane or something like that, because in the real world, there's something called air resistance. And in fact, this is not your free body diagram. Oh, I wrote FG, I meant FN. You would actually have air resistance going upward, and that would be the thing that you are feeling, and so you would feel not weightless. If you are just in a world with no oxygen, then yeah, jumping out of anything is going to make you feel weightless. All right, key takeaways. Apparent weight is equal to your normal force. So if you find your normal force, that is what you're feeling as your weight. If I'm accelerating upward, I'm going to feel heavier. If I'm accelerating downward, I feel lighter. All right, bye.